All right, this video focuses on what we call conjugates. Go ahead and pause and read. All right, radical expressions that involve sum and difference of the same two terms are called conjugates. So if we have a radical set, a plus, or it's the square root of a plus the square root of b, the conjugate, we look at this sign right here, and we're going to take the opposite of it, minus. So these are considered conjugates of each other. When you multiply conjugates, and you FOIL it out, first, outside, inside, last, the middle terms will always cancel out. So you're going to be left with a minus b. So down below here are a couple examples. Here is our original expression. The conjugate of the denominator, so here's my denominator, 5 plus the square root of 3. The conjugate is going to be 5 minus the square root of 3. Again, it's the opposite sign of this. All right, second example. Here's an expression. We look at the denominator, and we're looking at the conjugate. The conjugate is going to be 3 square roots of 2 plus 4. All right, how does this help us? Conjugates. We've spent some time already dealing with multiplying, or actually rationalizing denominators of a single root. So for example, don't need to write this down, 5 over the square root of 3. The denominator has a single radical. In order for us to rationalize it, we learned already that you just take the numerator and the denominator by the square root of 3, and then you multiply across. 5 square roots of 3 over square root of 3 times square root of 3 is square root of 9. 5 square roots of 3 over 3. All right, that's if you have a single denominator. Look at the difference in this example. This one has 2 terms down here. Well, we can't do that quick, just multiply by the square root of 3 to the numerator and denominator by rationalizing. We have to find its conjugate. So the conjugate of this is 5 minus the square root of 3. Again, the denominator. All right, I'm going to go ahead and erase this, because we don't really need that. That was just a practice problem from something earlier we've learned in rationalizing denominators. Okay, so we're going to rationalize this denominator when it contains 2 terms. So we just identified the conjugate, 5 minus the square root of 3. So now, here's my original expression, 7 over 5 plus the square root of 3. So that's the original. I'm going to go ahead and put parentheses here. I'm going to multiply. I'm going to multiply by its conjugate. So here's our conjugate, 5 minus the square root of 3. I have to do this to both the numerator and the denominator. So 5 minus the square root of 3 over 5 minus the square root of 3. All right, so what we're going to do is we're going to go ahead and multiply across. 7 times 5 minus the square root of 3. So I'm multiplying across. Now, if you remember from this previous slide, oops, here we are, multiplying conjugates. What happens is when you FOIL them, first, outside, inside, last, the middle terms are going to cancel. The radicals are going to cancel, and you're left with a minus b. So what I'm going to do is I'm going to show you this down below. Now, you don't have to go through this much work when you actually go through and multiply. So I'm going to do first, outside, inside, last. So first is 5 times 5 is 25. I'm going to go to outside. 5 times negative square root of 3 is negative 5 square roots of 3. So done first and outside. Now I'm going to go to inside. The square root of 3 times 5 is 5 square roots of 3. I'm going to go to last. Square root of 3 times negative square root of 3 is negative square root of 9. All right, now look at the 2 middle terms. They cancel out. Gone. All right, I'm not going to touch the purple besides distributing the 7 through. So distribute the 7, so 7 times 5 is 35, minus 7 square roots of 3. The denominator, square root of 9 is a perfect with 3. So notice, here is your A, here is your B. A minus B, what we said earlier. So 35 minus 7 over the square root of 3, and then 25 minus 3 is 22. So that's how you rationalize when you have two terms. You have to multiply by its complex conjugate, its conjugate.